Hi you guys, this is Mrs. King. I actually don't feel very good, so this is Monday morning and I'm making this homework help video which I actually wasn't going to make, but I don't think I'm going to be running the class today. So I'm gonna basically go over your homework, okay? So your homework is a Google form. Remember last week we took a few pages of notes. It's on that homework. The nice thing is last week on Thursday and Friday, your homework was a Go Math. Now these 10 problems are almost identical to the 7 problems that you did on Go Math. Because they kind of come from the same source. Anyway, so watch the video, work on the problems, and then I will be available for tutoring tomorrow. Okay? All right, so let's start. Number 1. It says find equivalent rates using a multiplicative relationship. So as you see 2 tables. And it has a ratio of apples to oranges. So first thing I'm going to do is I am going to draw the 2 tables. It has 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm going to skip a few lines and draw the second table as well. Okay, and I'm going to title this Apples and Oranges. So just using the first letter, 9 to 10, 18 to 20, 27, 36, 4 to 5, 8, 12, and 16. Okay, so find equivalent rates. So what I'm going to do is I'm going to use multiplicative relationship. So always going to your first initial original ratio when you're multiplying or dividing to find equivalent rates. So obviously this is 9 times 2 and 10 times 2. So this table is made by multiplying by 2. So if you take a look here, 9 times 3 is 27. So if you do the same thing, 10 times 3, that makes it 30 here. 9 times 4 is 36. So if you do 10 times 4, then you get 40. Using that same strategy, now I'm going to do the other table. So, I missed So let's first double check with the equivalent ratio that you already have right here. So 4 times 4 is 16 and 5 times 4 is 20. So same multiplicative relationship. Here this is 4 times 2 is 8. So you need to do 5 times 2, which is 10. Over here, this is 4 times 3 is 12. So you would do 5 times 3, which is 15. Now I need to find the blanks. So my first 2 blanks are 30 and 40, and then my second are 10 and 15. So 30 and 40, 10 and 15, and all you need to do is just choose the answer. I'm not going to be choosing the answers for you, but that's how you do it. Okay, let's go to number 2. It says, George is a first grader and reads 43 words per minute. How many words can he read in 5 minutes? It says proportion. Remember, proportion is when one ratio is equivalent to another ratio. So let's first go ahead and set up the proportion. So I'm going to do words on top, minutes on the bottom. It says 43 words per minute. So that means 43 words over 1 minute. Per minute means 1 minute. Now I'm going to set it equal to, and then it says how many words So blank words in 5 minutes. This is a proportion method, okay? Now, I know that 1 times 5 is 5. So then 43 times 5, and then you can bring in your calculator. 43 times 5, 215. So 215 words in 5 minutes. Number 3, equivalent ratios. Find the equivalent ratios that have blank. Then compare the first terms. So remember, when we want to compare two or more two ratios or rates or fractions, you want to make sure that your denominator is the same. That way your numerator is what you can look and compare. So the answer would be find equivalent ratios that have the same second term, same denominator. Number 4. The Sacedo family paid $16 for 4 movie tickets. How much would they have paid for 16 movie tickets? Same as number 2. So I'm not going to solve it, but I am going to set it up. Okay, money always goes on top. So first I'm gonna put $16 for 4 tickets. Set it equal to blank dollars for 16 tickets. And to find the blank, we do the multiplicative relationship, which is first you do the 1 here, and then whatever you get there, you do the same thing here. Okay? Multiply by what? Multiply by what? All right. Number 5. Mrs. King's car used 12 gallons of gas on a 300-mile trip. Mrs. Anderson's car used 5 gallons of gas on a 135-mile trip. Whose car got more miles per gallon? And then it says, in parentheses, use unit rate. Okay? So in order to compare, remember the Edpuzzle video with the car, 2 cars, miles on top, hours on the bottom? In order to compare, we found the unit rate and made the denominator 1, right? Then we compare by looking at the numerators. So for Mrs. Kang, 12 gallons of gas on a 300-mile trip. So what I'm going to do is I'm going to write Kang, so K, 300 miles on top. Oh, I'm sorry, not dollars. I wish. 300 miles over 12 gallons. I'm going to skip some space and write Mrs. Anderson's first. 135 miles, 5 gallons. And I'm going to find the unit rate because right now I can't really compare. So to find the unit rate, you always divide by the denominator. So the first one, I'm going to divide by 12. And the second one, I'm going to divide by 5. So 300 divided by 12, I get 25. That means 25 miles for 1 gallon. Now let me find the other unit rate. So 135 divided by 5, I get 27 miles for 1 gallon. Now, if this was money and the question was which is a better buy, then it'll be this one. $25 per gallon is cheaper. But that's not the question. This one says whose car got more miles per gallon. You're actually looking for the one that you're able to drive more per gallon. So the answer is Mrs. Anderson's. She can go 27 miles per gallon as opposed to I can only go 25 miles per gallon. Okay. All right. Now, number 6. Tommy drove 260 miles in 4 hours. Joe drove 201 miles in 3 hours. At those rates, could either man drive 128 miles in 2 hours? Parentheses, unit rate. That means use unit rate again. So again, just like number 5, it's similar to number 5, so I'm not going to actually solve both, but I will set them up. Let me actually use the space here. Okay, so this is number 6. So first I'm gonna write Tommy's 260 miles in 4 hours, and you're gonna solve by dividing by 4 and see the unit rate. And Joe, I'm gonna write 201 miles in 3 hours, and this one I'm going to divide by 3 to find the unit rate. But remember, once you do that, the question is not what is the unit rate. It says at these rates, could either man drive 128 miles in 2 hours? Okay, so I guess I needed more space here. Actually, I'm going to do this problem, okay? Let me actually go here, set up the same problem again. All I'm doing right now is I'm copying the rates that I wrote. Okay, Tommy and Joe. Let me just start over. So first thing I'm going to do is find the unit rate by dividing by the denominator. Okay, just like number 5. So 260 miles, divide by 4, you get 65 miles per hour. Now, for Joe, 201 divided by 3 hours, you get 67 miles per hour. Now, but if you look, it says at this rate, can they drive 120 miles in 2 hours? So what I'm going to do now is I'm going to set up an equivalent rate with 2 hours. And I'm going to find how many miles for 2 hours. To see either one or both or neither can drive 128 miles in 2 hours. So if you look at the multiplicative relationship, it is times 2. 1 times 2 is 2. So 65 times 2 is 130. If you're not sure, all you need to do is just use your calculator. So 130 miles in 2 hours. And then for Joe, you would do the same thing. You would multiply by 2. So 67 times 2 is 134 miles in 2 hours. So looking at your answers, 130 miles in 2 hours and 134 miles in 2 hours. So they both can drive at least 128 miles in 2 hours. So then you would choose that answer. Let's look at number 7. In 15 minutes, Lena can finish 2 math problems. At that rate, how many math problems can she finish in 75 minutes? That's the exact same problem that we had in our notes. You know what? So just to make sure that you guys actually did take notes, why don't I give you the page number? And you guys can refer to the problem there. So if you look at your math notebook, page 12, okay, it's that one, okay? So if you take a look, it says, in 15 minutes, Lena can finish 2 math problems. At that rate, how many math problems can she finish in 75 minutes? Exactly the same problem. So if you need help, refer to page 12. Okay? Okay, next one. An In-N-Out sells 25 drinks every 20 minutes. At that rate, how many drinks will In-N-Out sell every hour? Now, so we're gonna write equivalent rates. Okay. However, one thing you need to keep in mind is this. So on the first sentence, it says 25 drinks every 20 minutes. Okay. So, and then on the next one, it says how many drinks sell every hour. You cannot use 20 minutes with 1 hour. You either need to have both minutes or both hours. The units must match. That's why it says 60 minutes is equivalent to 1 hour. So they want you to use, instead of 1 hour, they want you to think and use 60 minutes. Okay. I'm not going to solve it, but I will set it up in case anybody needs help. So I'm going to do drinks on top, minutes on the bottom. 25 drinks coming from the first sentence, 20 minutes. And I'm going to set it equal to, I'm going to make a proportion, make equivalent ratio or rate. And I know that I want to find out how many drinks in 60 minutes, because 60 minutes is equivalent to an hour. Do not use 1 because then you're saying 1 minute, okay? And you're going to use multiplicative relationship to find what goes in the blank. 20 times what is 60? Then do 25 times what gives you your answer. Okay, number 9. Craig's art teacher mixes 8 pints of yellow paint with 4 pints of blue paint to create green paint. Craig mixes 10 pints of yellow paint with 5 pints of blue paint. Did Craig use the same ratio of yellow paint to blue paint that his teacher used? And then it says parentheses, equivalent ratios. Okay, so there's 2 ways to see if the ratios are equivalent or not. If you take a look at page, I believe 10 or 11, we talked about the 2 different ways in which how you can find if the ratios are equivalent or not. One of them is to simplify the ratios. And then the second way is to rewrite the ratios with common denominator. This is the method that they want you to use, okay? Equivalent ratios, ratios with common denominators. So, number 9. First, I'm gonna do teacher. So for T, the ratio of yellow paint to blue paint is 8:4. Okay, then I'm going to write the ratio that Craig used, which is, let me actually give more space. 10 pints of yellow paint with 5 pints of blue paint. Okay, so let me actually solve this problem using both of the ways. So I'm going to write it twice. I'm going to use both simplifying method and the equivalent ratio method. Okay, so if you were to simplify, then all you need to do is just simplify to the lowest term. I can see that I can divide this by 4, which would give me 2:1 ratio. Now for this ratio, I can divide by 5. And that would give me also 2:1 ratio. Since 2:1 is equivalent to 2:1, equivalent ratio, so I know that they are equivalent. Okay, so first of all, the answer is there, but keep watching. You can also rewrite them with common denominator. So if you look at 4 and 5, the common denominator of 4 and 5 is 20. Okay, multiples of 4, multiples of 5 if you keep going. So then I can rewrite it with 20 on the denominator for both and then compare the numerators. To do that, with this one, I would need to multiply by 5. 4 times 5 is 20. 8 times 5 is 40. Here, I need to multiply by 4. 5 times 4 is 20. 10 times 4 is 40. And if you take a look, since when you rewrite them with common denominator, And when you're comparing the numerators, notice that your numerators are the same. They are equivalent. So again, it confirms that the answer is yes. Okay. Last one. One oak tree grew 6 feet in 2 years. A sequoia tree grew 14 feet in 7 years. Which tree grew faster? Well, to see that, you can find the unit rate for both and then compare the numerators. So what I'm going to do is first, I'm going to just do O for oak tree. 6 feet over 2 years. And I'm going to divide by the denominator to find the unit rate. The other one, I'm going to say S. And that's 14 feet over 7 years. And I'm going to divide by 7 to find the unit rate. So 6 divided by 2 is 3. So this tree grows 3 feet per year. 14 divided by 7 is 2. So this tree grew 2 feet per year. So when you're comparing and you're trying to see which tree grew faster, you can clearly see that the one that grows 3 feet per year is growing faster than the one that grows 2 feet per year. Okay, all right. So hopefully that helps. And yep, there you go. Bye.